Okay, Unit 2 review. Hopefully this video is a little bit better quality compared to the last ones I put out there. I'm not going to do every single question. I'm just going to do an example of each question so you can kind of see what's going on. So number one, it's asking you to identify the leading term, the end behavior, and the constant term. Okay, so a couple options that you have is you could take these factors and box them like you see down here, or here's a couple shortcuts. Okay, so let's start with the leading term. The leading term is going to be your initial x value. The leading term is just the first x value that you see. Okay, so if you look at this, we just have x, x, 2x, and x. All right, so our degree here is going to be 4 because you see 4 x's. So we know that whatever we see is going to be x to the 4th because we see 1, 2, 3, 4 x's. So you know whatever you see is going to be x to the 4th. Now for the number in front of x to the 4th, you just take the number in front of the x on each of these and multiply them. So when you just see a regular x right here, the coefficient of that, or the number that's right here that we don't see, is 1. So it's 1x, 1x, 2x, 1x. And if we multiply all those, that will give us our number in front of this. 1x times 1x times 2x times 1x. Okay, so 1 times 1 is 1, 1 times 2 is 2, and 2 times 1 is 2. So your leading term is 2x to the 4th. Okay. Your end behavior, based off your degree, tells you your end behavior. So our degree is 4. That's an even number. So our end behavior means that both endpoints are going to be going the same direction. All right, so it's going to look either like this or like this in some form where both arrows are going the same exact direction. And then your constant term, you're going to do the same things that you did with the x, except with the constants. So we have 1, -3, +5, and 2. You're just going to multiply all those, okay? So 1 times -3 times +5 times +2 is -30. So your constant is -30. And once again, all I did was I multiplied 1 by -3 by +5 by +2 on my calculator. Okay, so skipping down to number 2. The following equations are given in factored form, convert to standard, so we're just going to box it. Okay, so for this one, I have x in -4, x in +3, and then inside the box is just the multiplication of those. Combine like terms, these boxes will always be your like terms, so then you end up with x squared minus x minus 12, and then you have to multiply the 3x minus 2. So 3x -2. Okay, so we multiplied these two factors in this box, and that gave us this, which is this, okay? But we still had one more factor to do. So then multiply everything in the box, 3x cubed, -3x squared, -36x, -2x squared, +2x, and +24. And then we combine like terms. 3x cubed is the only x cubed you see, so that goes first. That's your leading term. -2x squared and -3x squared is -5x squared. 2x minus 36x is -34x. And +24 is what's left, and that's your constant. Okay? So leading term right here, constant right here. You would do the same thing for this one. The only thing that's different about this is with this term, you have to distribute the 2, meaning that it would be 2x plus 2, because 2 times 1 is 2, and then 2x and 1 on the side. Okay. For number 3, identify the zeros of the following equations in factored form. So all you're going to do is look at each one of these. So I'm going to look at B right here. Okay. This x out front always equals a 0, and here's why. Okay, if we look at these two, I know that x minus 5, this is going to give me an x-intercept of +5. All right, and the reason we know that is because we're just taking the opposite of what's inside parentheses. But the math behind that is that you take x minus 5 and you set it equal to 0. And then when you solve for x, you end up getting a +5. That's the math behind it, okay? So if I did that with 5x minus 8, I have 5x minus 8 equals 0. 5x equals 8. X equals 8 over 5. So then I have 8/5. And then if I did this one isn't being added to or subtracted from, it's just x. So to solve for it, I would just set it equal to 0. Oh, x is equal to 0. There we go. Okay, a key thing to know about this is that the x-intercept, or the 0 of 5, happens 3 times, okay? So it's actually 5, 5, 5, 8/5, and 0. For number 4, they want us to identify the point of intersection. So you're going to start by going to the graph. You're going to type in this equation for y1. So x plus 4 and x minus 7. And then for y2, you're going to do 3x minus 1 and x plus 4. Okay, so then you go to the graph. Here's your standard view. There's 1. Here's the other one. So pretty similar graph. So what we're going to do is go to the table. You hit the blue button and then the graph button, and we're looking for similarities, okay? So we know that there should be 2 intersection points. And what you're looking for is the same number in both the blue and the red, okay? So right here we have -4, 0, and 0. That means -4 and 0 is one intersection point, okay? So now we got to keep looking. Try to see if we see anything. Any similarities. Okay, so as you go higher and higher, you're getting farther and farther away. And there it is. Okay, so I overlooked it. -4 and 0 is one of them, and then -3 and 10 is the other one, because you can see that they're the same. -4, 0, -3, and 10. All right, so all you're doing when you're looking for intersections is where they're the same on the blue and the red column. When they're the same number, so -10, -10, 0, 0, those are your intersection points. All right, for number 5. Based off the polynomial, create a sketch. So it's just going to be a rough sketch. Each one of these is going to be your x-intercepts, okay? So your x-intercepts are -6, +5, and -2/3. And then our degree is 3, because there's 1, 2, 3 x-intercepts. So that's odd, which means our endpoints are opposite, okay? Then you want to identify if it's going to be a positive or a negative graph. You look out front, it's positive. So what it means when it's positive is that you have one endpoint going this way and another endpoint going this way. They're on opposite ends, but it's positive because the right side's going up. All right? Then you want to plot a point at each one of these. So at -6, +5, and -2/3, that's just somewhere right here. And each one of these only happens once. They all have a multiplicity of 1. So you're going to come through each one and connect the dots. So it says to include the y-intercept. I didn't do that, but you can identify the y-intercept by multiplying 6 by -5 by +2. 6 times -5 is -30, times 2 is -60. So what that means is that this point is going to be all the way down here at -60. And that's what you would do for all of them. All right, for number 6, the polynomial is defined by this. If x minus 1 is a factor, write in factored form. So you're going to take x minus 1, and you're going to work backwards to solve this. We have to figure out what we multiplied x minus 1 by to get this. In the first box is the first term, so x cubed. X times what gives me x cubed? X squared, which means this is -x squared down here. So now I'm at -x squared. I need -x squared to become a positive 8x squared, and I do that by adding 9x squared. That's what goes in this box. So I have -x squared. I need it to become a positive 8x squared. The way I do that is by adding 9x squared. X times 9x gives me 9x squared, so that's a -9x. I'm at -9x. I need to be at positive 11, so that is a positive 20x. So that gives me 20, and this gives me -20. And if you look, that's the same exact thing, okay? So what I'm going to do right now is we're just going to stop with that. X minus 1 and x squared plus 9x plus 20 because we haven't talked about factoring this yet, but we will. So this right here for now will be your answer. All right, and so that would be the same thing for number 7 and number 8. Number 9, they give you all of this and they say if x minus 3 is a factor, what is the value of a at? Okay, so we're trying to solve for the term next to the x right here. So we're going to be plugging this in for x. So what that means is we have to plug in the actual x-intercept. So you plug in 3 for all the x's, okay? So you have 3 cubed plus a times 3 squared minus 5 times 3 minus 75. All right, so all I did was I plugged in a positive 3 because that's my x-intercept, and for all these x's. 3 cubed is 27. This becomes 9a. This is minus 15, and this is minus 75, and it's all equal to 0. Combine the like terms. So 27 minus 15 minus 75 is a negative 63. So then this becomes 9a minus 63 equals 0. But we're trying to solve for a. So we're going to move the 63 over. 9a equals positive 63. Divide by the number next to a, which is 9. So 63 divided by 9 is 7. So a equals 7. All you do is you plug in the opposite. So here's your factor. Plug in the x-intercept everywhere you see x. Combine the like terms. Get those like terms to the other side and divide by the number next to a. All right, number 11, which of these polynomials could have x minus 2 as a factor? You're going to want to do the box for each of these and see which one works out. And then number 12 is a tough one that we haven't really seen before, but it's going to be pretty simple. So Evan is making an open box out of paper that's 5 by 7 and then folds the sides up. All we care about is this right here. So they ask, what is a reasonable domain? So the domain is going to be where it's positive because you don't want this negativity right here. So this doesn't matter, okay? And this also doesn't matter because that's going to go on forever, so that doesn't count. From here to here is our good domain. So from 0 to about 2.5, okay? From here to here is a good domain. So what value of x will give Evan the greatest volume? That's going to be the x value that's associated with this because that's the highest point in our domain. Okay? So if you look at this, that's about 1. So we'll call it approximately 1 because when x equals 1, that's where we have our maximum. Based on the graph, how large could the cutouts be to create a volume, to create a box with a volume of 10 inches? So that's going to be this side. So you see 10 right here. That's significantly less than half. So we'll call it about 1/4.